Welcome to lesson 4. In this lesson you'll learn how to work with text files. Working with text files is an essential skill for Linux administrators, as much of the configuration of your server is written to text files. That means that you don't only need to know how to read them, but also how to filter the contents of text files in the most efficient way. We'll talk about some of the basics about working with regular expressions, as well as essential text file tools like tail, tr, grep, awk, and many more. Working with text files often means that you need to find text files containing certain text. And also it means that you need to replace text in an automated way. And if you want to do that the smart way, regular expressions are a great help. So before starting to talk about the real utilities that you are going to use to treat your text files, we need to talk about regular expressions. So to understand regular expressions, you should know that these are text patterns that are used by tools like grep and other utilities. Something that often happens is that people confuse regular expressions with globbing. In the previous lesson you have learned about globbing and how globbing can help you finding files that match a certain pattern. Regular expression is doing more or less the same thing, but now it is doing it on the contents of a text file. And what is difficult is that regular expressions look like globbing, but they are not the same. And that is confusing. Let's have a look at an example where we are using the grep utility. I'm using grep a star on a star. Now what exactly is this doing? The a star, which is between the single quotes, is a regular expression. And the a star that is at the end of the command is globbing. So the star relates to the a in the regular expression and the star relates to the a in globbing, and they have a totally different meaning. We'll see shortly what exactly it means if you use a star in a regular expression. But probably you don't want to do that. What you should also know is that regular expressions are for use with specific tools only. You cannot just use them with all tools. They only work with tools that have been developed to work with regular expressions. And some well-known examples are grep, vim, awk, and sad. If you want more information about regular expressions and everything that you can do with it, there's a man page that is in section 7. So the man item is called regex. So I really can recommend that you consult this man page to find more information about all the things that you can do with regular expressions. So on this slide we see a list of all the characters that can be used in a regular expression, their definition, and I included an example and the result that is given by the example. So the first regular expression is caret, and that defines start of a string. So if you are looking for caret ABC, you will find lines that start with ABC, like ABC, ABCDEF, and so on. Now where caret signifies the start of a line, $sign signifies the end of the line. So if you look for ABC $, well, the result will be anything that is ending with ABC. So then we have the dot, which you can also call period, which matches any character except new line. So in A.C, you get a match on ABC and on AAC and on A2C. The period is really like the question mark that we've seen in globbing before, but now this is for a regular expression. And then we have the vertical bar, which in Linux is also known as the pipe. And that is used for alteration. If you're looking for 1 or 8, you would write 1 pipe 8, and it would match lines containing a 1 and lines containing an 8. And then we have the curly brackets. That signifies an explicit quantity of the preceding character. So AB2C means that you will get a match on ABBC. And only ABBC, so if the string would be ABBC, that wouldn't match because you're looking for 2 B's and not 3 of them. Between the square brackets, we are looking for an explicit set of characters to match. So that would be one or the other. So A square bracket lowercase b, uppercase b, closing square bracket c, would give a match on A, B, C in the case where it's a lowercase or an uppercase letter. Then we have the round brackets that signifies a group of characters. So round brackets are especially useful if you are looking for a specific quantity of a specific group of characters, as in the example where the group of characters is 1, 2, 3, and we are looking for a quantity of 3 of them. So that would give a match on 1, 2, 3, 1, 2, 3, 1, 2, 3, and only that. So then we have star, which is also known as asterisk, which matches null or more of the preceding character. So if you would look for A, B, star, C, well, you would get a match on AC, because that's a match of null times B, or on ABC, or on A, B, 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 C. And whatever amount of B's you would have in your regular expression would match. Then we have plus, which matches one or more of the preceding character. So it's a little bit like star, but you need to have at least one. And then we have question mark, which is null or 1 of the preceding character. So A, B, question mark, C would give a match on AC and on ABC, but not on A, BBC. I know this is overwhelming, and regular expression really takes time to getting used to them. But they are useful, but they're not that important. So I don't think you should try to remember all of them during the exam. Just make sure that you can use the utilities that are using regular expressions, and that you can use some of the more common ones of them. Personally, I like caret, I like dollar, I like the alteration, and apart from that, I don't do much with regular expression, because there is always another way around them.
In this lesson you'll learn how to work with text files. Working with text files is important for the Linux administrator, because all the configuration of the Linux system and its services is stored in text files. No matter what it is, if you just want to add a user or configure a complicated SE/Linux policy, chances are that you end up modifying a text file at some point. One of the easy text file utilities that you can use is cat. This tool dumps the contents of a text file on the screen. Let's try it on the file cities that I've created in my home directory. The command cat cities just dumps the content on the screen and gives back the prompt immediately, which makes it a good utility for small text files. While cat is a great tool to see the contents of small text files, it doesn't work that good for larger files. Take for instance the default system log file in var log messages, which often contains many hundreds of lines. By just using cat on it, you would only see the contents scrolling by very fast. And that's not really readable. And that is why, for larger files, less is a much better utility. It opens a pager in which you can scroll all the way down to the file to find exactly what you need. While in less, a few useful commands are available as well. Especially if the text file is large, you will like the slash command, which allows you to search a specific string in the text file. So let's try a command like slash systemd, which is trying to locate messages generated by systemd process, and it will automatically highlight the first occurrence of the systemd word in it. And if you press N, you go to the next occurrence and the next and the next and the next and so on. To stop the page that is opened by using less, just press Q for quit. On Linux there are many utilities that deal with text files. Tail, for instance, shows you the last 10 lines of text files, and head by default shows the first 10 lines of files. You can modify that behavior by adding -n followed by a number to see more or less lines. Also very useful is still -f. This refreshes the display immediately as lines are added to the text file. This is very common practice on the var log messages file to see system events passing by in real time as they are logged to the file. So let's have a look at a few examples. Tail -n5 on etc passwd shows me the last 5 lines of the passwd file. head minus n20 of etc passwd gives the first 20 lines of the passwd file. And guess what? You can even combine them. Head minus n20 etc passwd followed by tail minus n1. This gives me line number 20. There are different ways of doing that, but this is just a nice way of combining the different commands together. Some other useful text utilities are cut and sort. With cut, you can filter a specific column out of a file. If, for example, I type cut cities, well, it gives me an error because I didn't tell it what exactly to filter out. To do that, I need the -F option. So cut -F1 cities would filter the first field out of the cities file. By default, cut does that based on the tab as the field separator, and that is why cities like San Francisco or San Jose are displayed correctly even if they have a space in it. If you want cut to filter on something else, well, you need to tell it what delimiter to use. Let's try cut -F1 on etc passwd, for example. There you can see that in etc passwd the fields are separated by a column. We didn't tell cut to look at the column as a field separator, and that's why we see the entire line. If we do want to filter based on the field separator, we need -d column to tell it that, well, the field separator is a column. And as you can see, all is fine now. After cutting a field from a text file, there are a few other tools that you can use on it, like sort, which sorts the contents of the file for you in the order of the ASCII table. That means numbers are displayed first, then every uppercase word is displayed, followed by the lowercase. The sort command has some useful options to tell how exactly context should be sorted, like sort -n, which sorts by number. So sort on the file numbers. As you can see, it doesn't sort it correctly because it doesn't recognize the numbers, but sort -n numbers is perfectly capable of sorting it the right way. What do you think of another example in sort file, which is a small file that I've created that contains some uppercase, some lowercase, and even one number. If you want sort to be case insensitive, we use the option -F, which doesn't make sense, by the way, but hey, this is Linux and not all the options do make sense. As you can see here, sort -F sorts the file correctly, no matter if it's an uppercase or a lowercase. A totally different utility that still relates to treating text files is tr. This command translates. Well, actually it replaces characters with other characters. A common example of tr is in echo, pipe, echo, hello, pipe, tr. tr is often used after a pipe to work on the output of one command. So tr a minus z, uppercase a minus z, and look at that, we can see that it shows all uppercase now. Now this works fine if in your language there are no accents or other characters at all that are put above or beneath letters. If you are using accents, you are better off using tr in a different way, which is with lower followed by upper. This just takes lowercase and uppercase, even if there's an accent on them, and this will always work well. By the way, you might be interested in the other options of sorting content in a useful way when working with tr. As you can see here, there are different ways of telling tr what exactly it should translate. So that's all for now. In the next lesson we'll have a look at grep, a great utility that works with regular expressions to find content in files. Grep is a very nice filtering utility. and you're going to use it all the times. So let's see how to use it. For example, if you do PSAUX to get an overview of all processes that are running on your system, it gives you, well, what you ask, all processes. If you pipe that to WC, you can see that's quite a lot of information, 307 lines. Now imagine that you are just looking for lines containing information about the HTTP process. You could do grep HTTP to get that information out of there. And by default the information is shown and the text you were looking for is shown in a color as well. Now another way of using grep is to search files. So if I would do grep Lisa on star, I would search the contents of all files in the etc directory for the text Lisa. Now we can see two things here. The first thing that we can see is that we get a lot of messages is a directory, and I don't want to see all those messages, so I'm going to redirect the error output to the null device, which makes the output a little bit cleaner. So the next thing that we can see is that right now we see the name of the matching file followed by the matching line, which means that some files are mentioned multiple times. If you don't like that, just do a grep -L, just do a list of the files, which is a little bit more readable. Now let me create a test file. Now let's add a test user. Add Lisa with an uppercase L. You know that Linux is case sensitive, so user Lisa with an uppercase L is a different user than user Lisa with a lowercase l. Now let's do grep Lisa without the -L again on star to display all lines. Oops, and I still don't want to see error messages, so I'm using 2 greater than def null to redirect them to the null device. So what you can see here is just lowercase l. And this is funny, we can also see a false positive, which is a localization. We can take care of that by using regular expressions, but that's not the subject of this lesson, so I don't care about the false positives. I do care about the fact that I don't see Lisa uppercase L. In order to take care of that, well, -I will do the job. -I stands for case insensitive. And what you can see here is that Lisa uppercase L is matched as well. Now grep has many useful options. Another useful option is the option -R. You can put all options together behind one dash in Linux. So I make that grep -I uppercase R. Uppercase R makes the grep recursive. And recursive means that it's going to search all subdirectories as well. Now what you can also see is that there are lots of binary file alternatives. I don't want to see those binary file alternatives, so I'm getting rid of them by using another grep, which is going to be an exclusive grep, grep -V binary. -V means don't show me all the lines containing the following text, and that will make the result a little bit cleaner. This is a lot of work, so we have to wait a little bit. I'm grabbing the entire directory tree under /etc, and you can hear the fan of my computer working very hard to give me the result. And now we can see some files appearing. So this is basically what I wanted to show you about grep. There are so many things that are different. There are so many things that are possible by using grep, and I just want to focus on the items that are the most important items, and I think we've got them here. So that's all for grep. So let's talk about set and awk. You are probably not going to like set and awk if you've never worked with them before. And the reason is that in the very old days of Unix, that is back in the 1970s, processing text files was very important. We didn't have nice monitors in that time. In most times there was just a printer connected to a computer. So you were working as an administrator kind in the blind. And if you're working without seeing anything, it is important to have the appropriate utility to get the right information out of a file. And that is kind of the time that sed and awk were invented to do powerful command line, file processing. Nowadays we don't need it anymore. There are people that are still using it, but there are also very good Linux administrators that don't use sed and awk at all. So let me do some examples. Let me do sed first. So sed to q on /etc passwd. Now what is that going to do? Well, it's going to show us the first 2 lines of the etc passwd file. Now let me try something else, like sed minus n followed by a nice regular expression. I want to see everything starting with the text root, and I want a p for print on the file etc passwd, and that shows me all the lines starting with the text root on etc passwd. Now there is a very good reason why people don't use sed as much anymore, and that is because much of the functionality that was previously only offered by sed can now be obtained by using other utilities. I mean, between this sed command or just grep --root on etc passwd, the result is the same, but the grep command is a lot nicer, and that is probably why you aren't going to use sed a lot. Now there's one thing that can be interesting. In order to do that, I need a backup of the passwd file. So let me copy etc passwd to my home directory. So I am in my home directory and I've got my passwd file. Let me show the contents of passwd, and we can see that there's a user with the name Linda. Now imagine that I want to replace Linda with something else. Then I can use sed minus I for interactive, and then I put the string, which is the operation that I want sed to be doing. So S for substitute, the old text is the text to be replaced with, the new text is the text to replace it with, and make that a global substitution as well. Oops, and it's telling me that we don't have any input file. So just type the name of the input file that you want to be using, and now you can see passwd has been processed. And the interesting thing is that the modification has been written directly to the passwd file. You can see no more Linda, but a Julia. This isn't very nice. We have 2 users Julia, but we will take care of that later. It's just the example, and hey, this is not etc passwd, this is a copy of passwd to my local home directory. Now another utility that you may be using sometimes is awk. Awk is also a utility that is doing many things that you can do with other files, with other tools as well. Now there is one thing that I do like to be doing with awk, and that is cutting out information. Let's do PSAUX, which is giving me a list of all processes. Now let's imagine that I want to grab the lines that contain the text Apache. There you go, and let's imagine that I need the second column. You could use cut minus F too, but you can see that cut has a hard time in recognizing the second field. Awk is a lot more precise. So if I do awk and then the awk command print $2, you can see that we have the second column. So if it is for filtering out columns of texts from whatever, awk is a useful command. And that is basically the only thing that I consider useful about awk nowadays. So if you do know how to use awk already and you know how to do many more things with it, that is fine with me, but you don't have to. This is just enough. So awk, after the command awk, we put between single quotes the command that you want awk to accomplish, which in this case is print, and $2 just refers to the second column. So if you want to have the sixth column, for example, make that $6 or whatever. So don't let set and awk confuse you, because they are difficult to use utilities. Just take care of what you really want to be doing with those utilities and you'll be all fine.
So let's have a look at the exercise. First, I would like you to use head and tail to display the fifth line of the file etc passwd. And next, I would like you to use sed to do the same. That's just to show you that you can use different utilities to accomplish specific tasks working with text files. In the third question, I ask you to use awk in a pipe to filter the first column out of the results of the command ps-aux. And then I would like you to use grep to show names of all files in etc that have lines starting with the text root. Following that, you should use grep to show all lines from all files in etc that contain exactly 3 characters, and that's all.
In the exercise, I ask you to use some of the text processing and filtering utilities. So the first question was to use head and tail to display the fifth line of the file etc passwd. So if I do head -n5 on etc passwd to start with, I see the first 5 lines, and if I do a tail -n1 on that, I see the fifth line of the passwd file. I think this is the easiest way of doing it. The second question asks to do the same using sed. So if you want to do this with sed, the thing would be sed -n and then 5p for print on etc passwd, and that also works. The next question was to use awk in a pipe to filter the first column out of the result of the command ps-aux. So ps-aux is giving us lots of information, and if you want to get a specific column out of there, awk is an excellent utility to do that, like print $1. Do notice the syntax with the curly brackets and the single quotes that are needed to interpret it well, and that gives us the first column of the ps-aux command. Next, we want to use grep to show the names of all files in etc that have lines starting with the text root. I like going to the target directory for an exercise like that. So grep root star is a good beginning, but if you do that, you get all lines containing the text root. And we just want to see lines that are starting with root. And this is how you do it. What is not so nice is that it's giving a lot of error messages, so let's redirect those to the null device as well. And this gives a clear overview of what we wanted. In question number 5, I asked you to look for files in etc that contain lines that have 3 characters only. So to do that, you need grep as well, followed by a regular expression which tells us that it should start with any character, any character, any character, and end with that as well. And let's do that in star. And if you want to get rid of the error messages as well, you can see that it's nicely displaying all matching lines here.
Some lines don't like to be matching, but there are definitely spaces or something else in there. FI, for example, and do, for example, that is something that you typically see in shell scripting structures with a tab in front of them. So let's consider that a match as well. And that was the exercise.
So this was a lesson about working with text files. Working with text files is an essential skill for Linux administrators, so you should be capable of working with important utilities. The most important utility that we've seen in this lesson is grep. Make sure that you know how to handle it, because really you can do very much with it, and it's a very useful utility. The other utilities, well, they are more specific for certain tasks, and you won't use them as often. But at least you have an idea of what they can do, and hopefully they can be of help at some point in time.